Okay, so the 1-5 we talked about supplementary angles, complementary angles, vertical angles, adjacent angles. What am I missing? Linear pair? Yeah. Okay. All that's in here. So number 1 says 1 and 2 are supplementary. If 1 is 97, find 2. What does supplementary mean? 180. So if I subtract 97 from 180, you get what? 83 degrees. Okay. 2 says angle 3 and angle 4 are complementary. If measure of angle 3 is 74, find the measure of angle 4. What is complementary? 90. So if I subtract 74 from 90, 16. Okay. If you get a question that asks for an angle, like let's say it said find the complement to an angle that's 92 degrees. If it's bigger than it, you can't have a negative angle. So there would just be no complement. Okay. Or if it was an angle bigger than 180 degrees, there would just be no supplement. Okay. You can't have a negative angle. Okay, and then 3 says find the measure of angle EFH. So in that diagram, you've got 2 angles that form a line. What are they called? Okay, all right, all of you are right. These 2 are opposite rays. Okay, these angles would be a linear pair, right? So then 3x minus 6 plus 2x plus 16 would equal what? So 5x plus 10 equals 180. 5x equals 170. Divide both sides by 5. I feel like we've had these numbers before, huh? Yeah. 34, right? Yeah. And then you want to take that and plug it back in. So EFH is here. 3 times 34 minus 6. 102 minus 6. We did have this one before, right? 96 degrees. Good. Questions? Okay. Number 4. Now what's that diagram of? Right angle. So if it's a right angle, what's true about the sum of those two? 90 degrees. 2x plus x plus 9 equals 90. And I get 3x equals 81. X equals 27. And it wants ABC. So I'm going to take that 27, plug it back in here. 27 plus 9. I feel like these are the same as yesterday's examples. Am I losing my mind? I feel like they're the same numbers. Okay. And then 5 says, is it possible to draw a figure that contains exactly 1 pair of vertical angles? So what does a vertical angle look like? Makes like the X. So if I make it here and I say that these are vertical angles, what did I just create the other side? Vertical angles. The answer there is no. Okay? It's not possible. You could say something like the opposite rays will form 2 pairs. Okay? Something like that. Questions on anything with the warm-up? So complements, supplement, linear pair, vertical angles, and adjacent angles. All things you're going to need to know from this section. 32 looks like this, right? And it asks you to solve for x and for y. So right now, all you know about this graph, measure-wise, is the lines form 180 degrees. Other than that, they don't give you any right angles, right? We will eventually learn that vertical angles are the same, but you don't even know that yet. So you can only group them by way of lines. So if I said these 2 here form a line, that means that 3x plus 8x plus 26 equals 180. So 11x plus 26 equals 180. 11x would equal 154. And then divide by 11. And x is 14. Then you got to take that and plug it back in here because the other relationship is that these 2 form a line. So 3 times 14, 42, right? 5y plus 38 plus 42 equals 180. 5y plus 80 equals 180. 5y equals 100. And y is 20. Makes sense now, right? Yeah?
So you have to subtract 42 first and then
Like
subtract
30? Let me go.
38 on the test.
Like 34 through, like, is this always, sometimes never? Sure. Yeah.
First I subtract 42.
You had to take the x and plug it back in here because these two are 180. Just the 3x, yep. Okay, this other challenge. The sum of the measures of two complementary angles exceeds the difference of their measures by 86. Find the measure of each angle and explain how you found the angle measurements. Okay, so we said it before, but remember if it says complementary and we don't know either of the angles, that one is x, and then what would the other one be? 90 minus x, right? So if one is x and it's complementary, the other one is 90 minus x. So these are my two angles. Angle 1, angle 2. Well, you haven't set it up yet. Yeah. Oh, I got you. Okay. Then it says the sum of the measures of the two complementary angles. So here's my sum. There's the sum. Exceeds the difference of their measures by 86. So exceeds means more than, right? So the sum is 86 more than the difference. This is the sum. The difference would be x minus 90 minus x. And that plus 86 equals the sum. This is a great standardized test question, just so you know. So these cancel, and I get 90 equals, this would be x minus 90 plus x plus 86. I get 2x minus 4. Add the 4. The setup is definitely the hard part. Yeah. 47 is your x. And then it says, what's the supplement, right? So 90 minus, not supplement, complement, sorry. And I get 43. And then you can check, like, if I add these two together, right, because that's the sum, is it going to be 86 more than the difference? So if I add them together, I get 90. And then if I find the difference, it's 4. 4 plus 86 is 90. So you can always check the ones that are set up like this. So we're going to go through everything you need to know for your test, which if I see you Tuesday will be Tuesday. And if you have nothing to do but sit in your house and study, then that's a great thing to do. Think about how prepared you'll be. All right, so the one was like all the definitions, right? It was the definition of a point, a line, a plane, possibly. So the point was the simplest form. Something like that. Simple. I'm not doing word for word for what the back of the book says, but it's the simplest shape in geometry, simplest object in geometry, okay? It is made up, like every single object is made up of these. Every object is made up of a point. A line is one dimension. Never ends. Oh, I missed the end. Dimensions. There we go. I teach math, not English, right? Never ends. Arrows at the end. Okay, and it can be named like AB or line AB, or if it had a lowercase letter that's italicized like that, it can also be line L. A point is named by a capital letter. Messy already. This is capital letter. Okay, a plane has two dimensions. It's got length and width, right? It has no edges, no thickness, It's named by 3 letters that are points that lie on the plane, right? Or a single letter that's not a point. Named by 3 letters. It's represented by something like that, but remember, it doesn't end. So I can either say that this is A, B, C, or I could call this plane M. Capital letter. What are collinear points? Good. Points lie on the same line. What are coplanar points? Good. What's the difference between a line and a line segment? Good. Line never ends. Line segment has endpoints, right? Has endpoints. Can be measured. Something like AB without anything over it is a line segment. Something like AB with a line segment over it is how it can be named. What's an endpoint? The point at the end of the segment, right? And really it's at the end of the segment or the ray. Okay, it's where your object stops in that direction. What's the difference between a line and a ray? Good. One endpoint, one arrow. This time the order of your letters matter, right? I can't call this ray BA. That's ray AB. If I drew that, then it would have an endpoint at the A, and it would have the arrow in the direction of B. Can you measure a ray? No. What are opposite rays?
Two rays going off one.
Good. Same endpoint, point in opposite directions. What was that? Good. Forms a line. So ray AC and ray AB in that diagram are opposite rays. Be careful how you name them. Remember, you guys made mistakes on your quiz, like how you ordered those letters. Make sure the arrow goes over the arrow. The end point should be what's shared. Okay, and then an intersection is what? Where two objects meet. It could be two lines, it could be two planes, it could be a plane and a line, right? And then think about all the intersections that we talked about, okay? How do two lines intersect? What would you call it where they meet? Less specific than that. The point. Yeah. How about a plane and a line? Also a point, yes? Think about your pencil or your stylus going through your iPad. Don't do it, but think about it. If it did, where it would meet, right, would be a point. Don't do that, please. All right, how about two planes? This is a line, right? So whether it looks like that or it crosses crisscross, either way, the intersection is here, which is a line. How would you name the intersection? So whatever these endpoints are, like if this is A, B, then the intersection would be line AB. Mm-hmm. Correct. The other ones are the points. The two where the two intersect, that's a point. The line through the plane, that's a point. But the two planes, that's a line.
So plane and plane line.
Correct. Good. Okay. All right. Then 1, 2, we got into coordinates. This is where we got like the numeric versions, right? So a coordinate is the number given to a point on a number line. Distance was also known as length. So you can either do the absolute value of the distance between the 2 points you could have counted on your number line, or you can do bigger coordinate minus smaller. Either way, you're getting the length. This is on a number line, so not a coordinate grid, not on a coordinate plane, but on a number line. So if this is 1, 2, 3, and you wanted to know the distance or the length of AC, it'd be 2. What are congruent segments? Brian. Good. Segments with the same length. Congruent in general means same size and shape, right? But if we're specifically talking about segments, then it's two segments that have the same length. And the segment addition postulate, yep. So super important. It's not going to go away. What does it basically mean?
Like AB plus BC, basically.
Good. So if B lies between it, right? If I have my segment and I've got A and I've got B, it doesn't have to be halfway, anywhere between there. AB plus BC equals AC. So this is where if you take a segment, you break it down into its parts, you can add it back together to get the whole. So this says given B lies between A and C, AB is 3x plus 10, BC is 2x plus 5, and AC is 30. Find x. Are you going to set those equal to each other? No. Not going to make that mistake again, right? Because you know nothing about the relationship between those two. What you do know that is if you add them together, God bless you, add them together, you can set them equal to what? Good. So 5x plus 15 equals 30. Good. 5x.
Incongruent segments with the same.
Segments with the same length. So this asks for x, right? It could also ask for A, B, or BC. What would you do there?
Plug it in.
Good. Plug them back in. Make sure you read the directions and know what it's asking for, because that's a crappy way to get points taken off, right? Is because you didn't read the instructions. All right. Then came 1, 3, which was midpoint and distance. The midpoint, by definition, is what? The point in the middle of a segment, right? Okay, the point in the middle, the point that cuts the segment in half, anything like that, okay? The point halfway between the two endpoints, anything like that could be the midpoint definition. What's the difference between that and a segment bisector?
It's a line like bisector.
Good. So a bisector doesn't have to be a point, right? A segment bisector would actually be a segment that cuts another segment in half. But a bisector doesn't, this one is a segment bisector, but a bisector doesn't have to be a segment. It could be a line, it could be a ray, it could be a plane, it could be a point. All you know is that it cuts whatever that is into two congruent parts. And you cannot bisect a line, right? And you cannot bisect a ray. Why not? Could. They never end. You couldn't find the middle. Okay, midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. And your answer is an xy coordinate point. And distance, square root of x2 minus x1 squared plus y2 minus y1 squared. Remember that distance is also known as the length of a segment. The difference between this and what we did in 1-2 is that in 1-2, that segment is horizontal or vertical. It lies along the same segment. Where in this case, God bless you, in this case, you're given coordinate points. So this could be a line that's like diagonal on your coordinate plane that you have to use the distance to find the length of. All right, the example there says given M or AB is bisected at point M. So you can see it either way. Given M is the midpoint of AB or AB is bisected at point M. Either way, it means you've got a segment. M is the midpoint, which means it's cutting it into two congruent parts. If AM is 2x plus 3 and MB is 4x plus 11, what do I do with those two segments? Good. Set them equal to each other. 2x plus 3 equals 4x plus 11. Subtract the 2x. Subtract, oh, that's really, well, that's fine. Subtract the 11. It's a bad example because you can't have a negative. You can have a negative x, you can't have a negative length, and if you plug that in, it's negative. But you get the point. I should change that sign. Now, the next one has coordinate points, right? So if you've got negative 3, 2, you can draw this out if you want. 1, 2, 3, 2, that's A. 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. That's B. This is not a horizontal or vertical line, so I can't count that distance. To find the length, I have to use the distance formula. So 6 minus a negative 3 becomes plus 3 squared. Plus 8 minus 2 squared. 9 squared, 6 squared, 81, 36. 117. So 117 is not even, okay? But if you add up the digits, I get 9. 9 is divisible by 3, so 3 goes into it. 3 and then 27 would be 9, and that's 3 and 13, which means this simplifies to 3 root 13. Okay, this is where a lot of you went south on the quiz when the midpoint, right? It says M is the midpoint of AB, A is negative 3, 2, and M is 1, negative 4. So this is an endpoint. This is a midpoint. So you got to separate them out. I would say x1 plus x2 over 2 equals the x of my midpoint. y1 plus y2 over 2. equals the y of my midpoint. And then I'm going to plug them in. So x1, y1, xm, ym. Hi, Mr. Hyde. All right, divided by 2 equals the x of my midpoint, which is 1. And then I got to multiply 2 on both sides. Negative 3 plus x2 equals 2. Add the 3, and the other endpoint's x is 5. With me so far? Yeah? Then I'm going to do the same thing with the y. So y1 is 2. y2 is what I don't know. Over 2 equals the ym is negative 4. Multiply 2 again on both sides. These cancel. Okay. Subtract the 2. And you get y2 is negative 10. So 5, negative 10 is the other endpoint. Questions? I would say that was probably the one, that besides the one where you set them equal to each other when they shouldn't, and one was angle addition. That was most missed, so be really careful with that one.
Mine too.
Yeah, same. Yeah. All right, 1-4, we got into classifying angles. This is the stuff you know really well, right? You've been doing this since elementary school. Okay, an angle, the sides are rays, right? So it's got 2 rays and it meets at a vertex. So that kind of takes care of all that, right? 2 rays with a shared endpoint. That endpoint is called the vertex. And the sides are rays. So if you name the sides, if this is A, B, C, when you name those sides, they have to be rays. And pay attention to the order of your letters, right? Because the rays, they matter. The vertex in that is B. And remember, there's 3 ways to name it if it's not a shared vertex. I can call it angle ABC, angle CBA, or just angle B. But as soon as that vertex is shared by another angle, I can know. Thank you so much.
Still being said? You call.
As soon as that's shared, you can no longer use B. Okay, congruent angles are what? Angles with the same measure. And an angle bisector is a ray that divides an angle into 2 congruent parts. And the bottom thing we just did up here. Okay, name the angle, the vertex, and the sides. Right? It's definitely close, so we're fine. So there's 4 ways to classify an angle by its measure. An acute angle is less than 90 degrees. A right angle is equal to 90 degrees. An obtuse angle is in between 90 but less than 180. And a straight angle is 180 degrees. The angle addition postulate says if B lies in the interior of angle ACD, then angle ACB plus angle CBCD equals angle ACD. And what it means is if you have an angle ACD and point B lies somewhere inside that angle, we basically just took and divided that angle into 2 parts. Now, we don't know that they're equal, but we do know that if we add those 2 parts back together, we get the whole. So the next thing says find M, or it should be point M, is the interior of angle ABC. So we've got angle ABC. And point M lies in the inside, which means it's divided into parts. If angle ABM, this one here is 52 degrees, and angle MBC is 48 degrees, find the measure of angle ABC. So ABC is the sum of those angles, 52 plus 48 degrees, and you get 100 degrees. The next one says, given ray BD bisects angle ABC. So angle bisector means it cuts the angle into half. So if I draw this out, A, B, C, and it says ray BD bisects, which means cuts it now into two congruent parts. So angle ABD is 5x plus 10. Angle, this should be DBC, 10x plus 25. I can now set these equal to each other. 5x plus 10 would equal 10x plus 25. Subtract the 5x from both sides. Subtract the 25 from both sides. Divide by 5. And x equals -3. So again, it shouldn't be negative because if you plug it back in, you'd get a negative, but you understand the process. Okay, the next thing says construct an angle that's 135 degrees. So if we used a protractor, we would have an exact. If we're approximating, 135 is a little bit bigger. It's in between, really. 90 degrees and 180. I could say that it's approximately 135 degrees. You won't be constructing with a protractor, but you might be asked to measure. All right, 1.5 says describe angle pair relationships. So complementary angles are two angles that sum to 90 degrees. Supplementary are two angles that sum to 180 degrees. Adjacent angles are angles that share a side and vertex, but do not overlap. So angle 1 and angle 2 here would be adjacent angles. A linear pair are adjacent angles whose non-shared side form a line or are opposite rays. So angle 1 and 2 here would be linear pair. And if they're a linear pair, they sum to 180. They're supplementary. And the last one is vertical angles. These angles formed by opposite rays. So angles 1 and 2 are vertical angles here. They make that X. Okay, last set of examples. So the first one says, given angle A is 63 degrees, find the complement to angle A and the supplement. So remember the complement is 90. So I would do 90 minus 63. And you get 27 degrees. That's the complement. The supplement is 180 minus 63. And you get 127 degrees. That's the supplement. Next one says angle A and B form a linear pair. So if I draw that out, I've got A and B. This is A, this is B. And it says angle A is 5x plus 20. Angle B is x minus 14. If they're a linear pair, it means they're supplementary. So 5x plus 20 plus x minus 14 equals 180. I get 6x plus 6 equals 180. 6x equals 174. And x equals 29. So this says, pay attention because it says find x and both angles. So once you get that 29, you've got to take them and plug them back in. So I'm going to plug them back into the x here. 5 times 29 plus 20. So 29 times 5, 145. Plus 20 is 165. That's angle A. And then you have two choices. One is plug the 29 in here and get that angle B is 29 minus 14, which is 15. Or take the 180 and subtract the 165 from it. Either way, you get 15. And if you've got the time, you want to do both to check. Next one says an angle is 20 more than its complement. So remember that we want to use variables to represent these. When you see the word complement, that means we don't know what the first angle is. So the first angle is x, and the complement would be 90 minus x. If it was supplement, it'd be 180 minus x. Now to establish the relationship, it says that an angle is 20 more than its complement. So it is this plus 20. So x equals 90 minus x plus 20. X equals 110 minus x. Add the x. 2x equals 110 and x equals 55. So that's the first angle. The second angle is 20 more than that, which would be, or sorry, the second angle, this is 55. So this is 90 minus 55. And 90 minus 55 is 35 degrees. You can also have just taken the 90 and subtracted the 55. Always compare them. So is this one 20 more than this one? And it is, so you know it works. And the last one says an angle is 20 more than its supplement. Find both angles. So now the angle is again your x. The supplement is 180 minus x. This angle is 20 more than this. So x equals 180 minus x plus 20. I'd get x equals 200 minus x, add the x, 2x equals 200, divide by 2, and x equals 100. That's one of your angles. The other one would be 180 minus 100, or 80 degrees. And then again, you want to check, is this one 20 more than the other? It is, so it works. Okay, remember to work out the chapter review that you either took on paper or that's on Canvas. All the answers are there, and the solutions worked out will be posted. And then also make sure you take advantage of the Quizlet for help with your terms. Have a safe weekend.